Hello everyone. So in this video, we will be talking about the third question of Biweekly Contest 130, which is minimum substring partition of equal character frequency. So first, let's go through the question and understand what it tries to say. Given a string S, you need to partition it into one or more balanced substrings. For example, if S is equals to ABA, BCC, then ABAB, CC, or the combination of AB, ABC, and C, or the whole string are valid partitions, but these partitions are not valid because the substrings that are represented in bold are not balanced. So we have to return the minimum number of substrings that we can partition S into. And they have also given the definition of substring, which is a balanced string is a string where each character in the string occurs the same number of times. So let's first understand what a balanced string is. So let's assume that the string S is A, B, C, D, E, right? Now, is the whole string S balanced? So the answer is no. Why? Because in the whole string S, A occurs two times, B occurs two times, but C occurs only one time. Same for D and E. But if we partition S into two parts, which is this AA, BB, and CDE, here A occurs two times and B occurs two times as well. So this part is balanced. Now the second part is CDE, where each of the distinct characters occurs only one time, right? Now we can partition this whole as a string to these two substrings. The other partitions can be AA and then BB and then CDE. This two can be in a single substring and BB can be in a single substring and CDE can be in a single substring. Other partitions can be A, B, B, C, D, E. I can partition here, and then I can partition here, and then I can partition here, and here. So in every substring, you can see that the number of times the characters in the substring those are present occurs same number of times. So there can be multiple partitions of this string. But what we need to do is we need to find the minimum number of partitions. Basically, the minimum number of substrings which can be formed as a result where the substrings have same number of the frequency of all the characters in the substring should be same, right? I think the ask of the question is pretty clear now here. Now let's go through the sample test cases that we are given. We are given an input string S, which is FABCCDDG. So S is FABCCDD and G, right? Yeah. How can we partition this so that the substrings which are formed as a result have the distinct combination of all the characters in them as the same frequency? So let's see. So F is present once in this whole string. So we will consider this F in the first substring and let's continue going forward. Let's say we considered A also in the same substring and let's continue. Let's say we considered B also and C also as all the frequencies for the characters present here are 1 right now. Let's see whether we can consider this C or not. If we consider this C now here in this substring, what we can say is F has only one occurrence, A has only one occurrence, B also has only one occurrence. So, as per the logic of the balanced string, we cannot consider C in this substring. So, what we will do is we will first get our partition here and then continue with the rest of our string. Let's say we considered C here as part of the second partition. Can we consider D? Yeah, as this also has only one occurrence here till now. Can we consider this second D? The partition that has already happened does not play any role in my this substring, the second substring. So C has only one occurrence, but D has two occurrences. So I will be considering my second partition till here for these two characters. So this will be my second partition. And for the third partition, let's see. Can we consider D? Yes, as it occurs once. G, yes, same frequency is 1. So we will be having three partitions, right, for this whole string. And the answer is also 3 for this case. And they have taken, so there can be two types of partitions. Here, FAB can be in a single partition. So let me write it again. FAB, CC, BD, and G. So they have taken FAB, CCDD, and G. Here the frequency is 1, here the frequency is 2, and same here the frequency is 1 as that of the initial partition. And the second type of partition is that what we considered previously. Let's see the second test case. So let's follow the similar method that we used previously. Let's say, can we consider this A in the first partition? Yeah. Can we consider this B? Yes. Can we consider this A? This will make the continuing partition imbalance. But let's consider this A in our current partition. So yeah, we have considered this A. So A occurs 2 times, B occurs uh, 1 times. But when I go to the fourth character here, which is B, the string gets balanced again. Similarly, can I consider this A? I cannot, because this will make the whole string imbalanced, but let's consider it because I have B as well as my next character. Let's say I considered this. Till now I've considered these partition as a balanced partition. Now can I consider this A? Let's say we consider this because B also is occurring somewhere after this A, right? I considered this A, but if I go further down, what I can see is C occurs only 2 times and D occurs only 2 times to get this B into my partition. So I cannot get this B into my partition because this will make the whole string imbalance. Because C occurs 2 times and the frequency of A here is 4 and the frequency of B is also 4. So I will be deciding to partition here, but no, this will be again wrong because A here occurs 4 times and B here occurs 3 times. So let's say I went back and did the partition here. Now what I can see is A occurs 3 times and B occurs 3 times. So my this partition is balanced. Now if I try to consider this my this whatever I'm marking here, this as a partition, not as a partition but as a string, which I will be dividing it into balanced substrings. How can I do this? When I try to consider this A in my further partition. Let's say I considered it. Can I consider this C? Yes. Let's say I consider this also. Can I consider this C right now? No, because A occurs only one time. So let's say I'm having my second partition here. I had my first partition here. I'm having my second partition here. So let's say I'm moving forward. Can I consider this C in my further partition? Let's say I considered this. Can I consider this D? It's yes. Let's say I considered this. Can I consider this D right now? No, because it will be making the frequency of D 2. So yeah, after this, I have only D and B, which I'm considered in the last partition. So how many substrings did I create using this method? This will be four, four substrings. And this I did greedily, hence I got four. Let's say how can we do further better than this? Let's say we are considering this as a partition and first partition, and then taking like dividing the further string that we are left with for the next partitions. So can I consider A here in the second partition? Yeah. B, yes. A, yes. B, yes. Can I consider A again? Let's say I considered this because I have P as well. But the frequency of A and B will be 3 and C and D will be 2. So I will have to divide again the string here and then same as the previous. These will be the other partitions. So how many partitions here did I create? 1, 2, 3, 4, and 5, which is more than the previous case. So let's take another partition. Can I consider this as a partition? Yes. So now in my string that I'm left with, I have A with frequency 2, B with frequency 2, C with frequency 2, and D with frequency 2. So I can consider this whole string or substring as a balanced substring. And the previous one that I got as a partition was already a balanced substring. So now in this case, I'm having only two substrings. So this will be the minimum case here, which I can, take as balanced partition of this whole as a string. As we have gone through two of the test cases that are given in the question, what we can observe is we cannot just consider the greedy approach as it can sometimes give us the optimal answer, but it cannot always give us the minimum value of the partitions because as we saw here in this test case, with the help of greedy approach, we could get four partitions, but if we consider the partitions in a different way, we could get even less than the greedy approach. So how can we do this? Let's talk about that. Let's consider the simple test case where we have the string as AABB. Here, what we will be doing is we will consider every cases of the partition of this string S and check whether the partition that we have already done is a balanced partition or not. So what I mean to say here is, let's say we consider this string A, B, and B, right? This is my initial state or where I have not done any partition. Let's say I am here at the initial index on A. Can I make a partition after A? I will be checking. Yeah, I can make a partition after A because A is only occurring once and there is no other character in this partition which will be imbalancing my substrate. So let's say I did a partition here. What will be my other choice? Let's say I did not do a partition here and I continued taking the path forward. So this will be my first case. I've already done a partition here. And this will be my second case where I have not done any partitions, right? Now going forward, what I can do is, let's say here in this case, I've already done a partition, so I will be considering this substring. So can I do a partition after A? Let's say I did, because A is only the single character. So what will be my result? A, which I've already done a partition with, and then again A, and then B, B. And let's say I did not choose to, divide this A. What will be my further string? This. Now, initially I was at here. Now I am here. I was in the previous step here. Now I will be at here. For this also, let's take after A, we did a partition. I am deciding to, you know, dividing this string after this B. So what I will be having is A, and then B, and then B. Now I'm at here. Let's say I am not dividing this anywhere. So where will I be at? Here. And the left one will only part if I'm having the previous substring balanced. Here also A, B. So I cannot now here. I cannot, do a partition here because this is an imbalanced string. So what I will be doing is my this choice does not even exist, but my this choice exists where I don't decide to divide the string. So what I can see here is if my string is of the length 4, I will be having 16, 16 choices. I had this choice, but I did not wish to take this because this was not giving me a valid partition. Now, what I can observe here is if I try to consider all these cases in a brute force manner, I will be getting a complexity of 2 to the power n, which is exponential. And this will not be considered as a right solution as the length of my input string is of the order 10 to the power 3. As we can go through this tree and analyze that, these solutions, the leaf nodes that are marked with red, are not balanced. Here we can see that A occurs 1 and B occurs 2 times. Similarly, here A occurs 2 times, but B occurs 1 times. But like what all observation we can make here so that we can reduce the time complexity from 2 to the power n to somewhat or something else. We can see that here, like the BB string has already been considered, or you can talk about this. This has already been considered. So why do I need to consider this again? This A, after that A is after A there is a partition, and after B there is a partition. This has also already been considered. So why do I need to again go and check here? So these repeated, computations can be uh, decreased by using dynamic programming, or we can use memoization to reduce the time complexity from 2 to the power n to n square. Let's see how we can do this. Let's say we are having two pointers. Let's say this is pointed as B, or then this is pointed as E, right? Which is previous and or C and current. Now my previous is also pointing at A and C is also, or the current one is also pointing at A, which makes the frequency of A as 1, or let's say we have a frequency array as well, where A's frequency is 1. I chose to, move C forward. Now I have two choices, whether I need to consider this A in my previous partition, or I will not consider this A in my previous partition. So if I want to consider this A in my previous partition, so I am not, dividing the array previously. So how my array will, or my current state will look like is AA and BB. But if I choose to, divide this A in my current uh, condition, so this will be the state looking like. So how can I represent this? Now I will be considering these two cases. If I want to consider this A in my previous partition, how can I call my function again recursively? And if I want to, divide the array previously, how can I call my, recursive function? Let's say for this case, what I did was I did not chose to, divide the string. That's why the previous will be the same. But if I chose to divide my string, what I will be doing is I'll again point my previous to the current state of where my current pointer is. This way, I can, choose to, either divide the string or not divide the string. Similarly, for every state, I can first check whether the current partition is balanced or not. If it is balanced, I will be having two options. Either I'll consider this in my continuous partition, which will be this option, and the other one will be divide this whole string or the current partition and move forward with whatever is left with me. Similarly, in this situation, I can choose either to, continue with this partition or, divide the string and continue with whatever is left with me as my two options. We will be going through the code for the particular explanation and see how it is being implemented. First of all, there is a Boolean function which checks whether the current state or the current substring is balanced or not. This is the whole recursive function, and this is the main function. So initially what I'm doing is taking the size of the um, input string, and I'm creating a frequency array as well of length 26, as we have given that. The input will be containing all the lowercase English letters. I'm creating a dp 2D vector which is of size n plus 4 multiplied by n plus 4. I am passing these data structures, which are frequency and dp, to the recursive function. And as I've already said, there will be a previous index pointer and a current index pointer. What I'm checking here is if the current index has already been greater than the length of the string, what I will be doing is I'll be checking whether the frequency array is balanced or not. If it is balanced, I will be returning 1, which will be contributing to the sum of the partitions, which I'll be returning as an answer. If it is not balanced, I'll be returning a very uh, big number, which will be eliminated in this min function. I am using the dp array as a memoization where I'm checking whether the previous index, whether basically the current substring is already I have checked or not. If I've already checked the current partition, and hence the value will be less than int max. And at that point of time, I'm returning this DP of previous and current. After that, if the DP of previous and current has not been already visited, what I'm doing is I'm trying to visit this by, setting the local variable where cur I'm taking as a very big number, and I'm increasing the frequency of the current character in the frequency array and checking whether the current partition is balanced or not. If it is balanced, what I'm doing is I'm creating another frequency uh, array as a new frequency array where all the characters has zero frequency, and I'm passing this as a new partition. 1 plus means I've already taken a partition, and I want to know what will be the answer for the rest of my string. And when I want to continue with the partition, what I'm doing here is I'm just continue with the previous index and current index, incrementing the current index. Here I'm incrementing both the uh, previous and current index to current index plus 1. Now at the end, what I'm doing is I am initializing the value which is cur into my DP of previous index and current index and returning it. In this way, I'll be solving this problem. Let's go through the sample test cases and try to see whether this gets accepted. This will get accepted, and same for all the rest of the cases, which will get accepted as well. Let's talk about the time complexity of this approach. So the time complexity will be, as here I am going through, I'm calling the recursive function, which initially would have been taken 2 to the power n as the time, but as we are using this DP array and memoizing the solution, we are doing it in n square time complexity. So the recursive function is taking n square, and the checking of the current frequency array, here I'm going through the frequency size, which is 26 every time. So it will be taking 26. I guess the approach and the time complexity is pretty much clear. So thank you.